Hello dear aspirants, this is Dr. Sourav Sir Classes. Our contact number is 98367 93076. Again, I am repeating our contact number which is 98367 93076, and our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange an out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay, like CSIN, NET, GATE, NVHM, TIFR, etc. So please feel free to contact if you need any help from us. So now we are going to solve a problem which is appeared in the GATE AI question paper, and the question is telling us that the sum of the elements in each row of A belongs to R to the power n cross n is 1. If B equals to AQ minus 2A square plus A, which one of the following statements is correct for X belongs to R to the power n? The option A is telling us that the equation Bx equals to 0 has no solution. Option B is telling us that the equation Bx equals to 0 has exactly two solutions. Option C is telling us that the equation Bx equals to 0 has infinitely many solutions. And option D is telling us that the equation Bx equals to 0 has a unique solution. So let us see what we can do from this. Okay. So let us understand the problem first. So we have a matrix. Let us be A belongs to R n cross with the property that the sum of the elements in each row is 1. We are given another matrix B is defined as equals to AQ minus 2A square plus. So we need to determine which of the given statements is about the equation Bx equals to 0 is correct for X belongs to R to the power n. So the options are these. So now let us analyze our matrix A. So first recall that the sum of elements in each row is 1. So this can be expressed as where 1 is the column vector of all ones in R to the power n. There, and this means that our lambda equals to lambda equals to 1 is an eigenvalue of A. As this is the row sum, no, we know that row sum is an eigenvalue of the given matrix. Lambda equals to 1 is an eigenvalue of A. Now, with a corresponding eigenvector 1, that means which is 1, 1, 1, 1 and all. So now expressing B in terms of A. So given B equals to, we got AQ minus 2A square plus, very good. So this can be factored as, our B can be factored as A into A square minus 2A plus I, that is equals to A into A minus I whole square. So our B is equals to A into A minus I whole square. So now the eigenvalues of A and B. So from the given thing, which is this, we know that our 1 is an eigenvalue of A, and let's consider the eigenvalues of B. If lambda is an eigenvalue of A, then the corresponding eigenvalue of B will be lambda into lambda minus 1 whole square. Eigenvalue of B, corresponding eigenvalue of B. So this is because our B is equals to A into A minus I whole square. So if our AV equals to lambda B, so our BB will be now BB is equals to A into A minus I whole square V, and that is equals to A into lambda minus 1 whole square V, and that will be equals to lambda into lambda minus 1 whole square V. Okay. Thus the eigenvalue of B are lambda into lambda minus 1 whole square, where lambda is an eigenvalue. Lambda are the eigenvalues of A. So determining the null space of B. So the equation now the equation Bx equals to 0 has non-trivial solutions. That means infinitely many solutions. If B is singular, meaning at least one eigenvalue of B is 0. So from eigenvalues of B, we can have our lambda into lambda minus 1 whole square equals to 0. As we got our lambda equals to 1 and 1 is an eigenvalue of A. So this implies, so if we get these things, so this implies two things. This implies lambda equals to 0 and lambda equals to 1. So lambda equals to 0, then A has an eigenvalue 0, then B is a corresponding eigenvalue 0. And lambda equals to 1, then lambda equals to 1 also makes B have an eigenvalue 0. Thus B has at least two eigenvalues that are 0 from a lambda equals to 0 and lambda equals to 1. Meaning B is singular and our Bx equals to 0 has infinitely many solutions. Wait, is that correct? Let me think again. Actually, the eigenvalue lambda equals to 1 of A leads to B having an eigenvalue which is 1 into 1 minus 1 whole square equals to 0. So lambda equals to 1 contributes to the null space of B. Similarly, if A has lambda equals to 0, that also contributes to the null space. But even without lambda equals to 0, lambda equals to 1 ensures that B has at least one 0 eigenvalue, making B singular. But the problem states that the sum of each row is 1, which implies lambda equals to 1 is indeed an eigenvalue, as our A1 is equals to 1. Therefore, B has at least one 0 eigenvalue, meaning our nullity of B is greater than equals to 1. So our Bx equals to 0 has infinitely many solutions, since the null space is at only one dimension, is at least one dimensional. Okay. So if there is more than one solution in any linear equations, we can easily say that they are infinitely many. So exactly two solutions will be not an option of it. So our option C is the correct answer of this question. So let us verify also. Now to ensure our reasoning is correct, let's take a simple example where our A is a 1 cross 1 matrix. Okay. That means a scalar matrix. So let it be our A B1. Now our B will be AQ minus 2A square plus, so that is 1 minus 2 into 1 plus 1, so that is equals to 0. Now, so our b equals to 0 and our bx equals to 0 becomes 0 into x equals to 0, which holds for all x belongs to R. So in this case, we can say that this is infinitely many, this has infinitely many solutions. Okay, so now let us our A to be 1 0 0 1. Then we can say that our A square is again I and our A cube is again I. So our B will be now, so from this our B will be I minus 2I plus I. So that is equals to null matrix. So again we are getting this thing, that means our 0x equals to 0. So our x should be anything. Okay. So let us take any non-identity example. So let us take our A to be 1 0 and again 1 0, because we have to check that our row sum is 1 and that is remain same for all rows. Okay, so each row sum is equals to 1. We can easily say that now from this we can say that our A square is equals to A and our A cube is equals to A square is equals to A. So our B should be now A minus 2A plus A, so that is equals to 0. So again B equals to 0, so the infinitely many 0 solutions conditions appear. Okay. Now another thing will arise. Consider, is there a case where our B is not 0, not the 0 matrix? Let's check. Let our A be 1 1 0. Okay. So then the row sums are 1. We can easily say that our A square is equals to A and A cube is equals to A. So again we are getting our B is 0. So this thing is not quite we are what we want. So let us take our A to be I3. So again we are getting B equals to 0. So let us take our A to be half, 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 and so then again also our A square is equals to A and A cube is equals to A and everything happens. It seems that in all the cases B equals to 0, leading infinitely many solutions Bx equals to 0. So let us give a let me give a general proof of it. So then it will be easier to see. So given that our A1 is equals to 1, we have A minus I 1 is equals to 0. So the 1 is in the null space of A minus I. We can say that, meaning our A minus I is singular. Now our B is equals to A into A minus I whole square. Since our A minus I is singular, A minus I whole square is also singular. Now, thus our B is singular and our Bx is equals to 0 has infinitely many solutions. Okay. So after carefully analyzing the properties of A and B and verifying with examples, we can easily say that the correct statement of this given question will be the equation Bx equals to 0 has infinitely many solutions. Okay. Hope you understood, guys. Again, I am telling that if you have any other mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange an out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you. Let's rock your examinations.